started. We got started a few minutes late here. We're having some projector problems. Anyway, so we're ready to go now, and just want to give a big shout out to some of our sponsors before we get started. Hurricane Labs, Invisium Security, Think Geek, yeah, and Trusted Signal. They each, just really wanted to thank them for helping support this. And without further ado, the first presenter is going to be Nick Berthaume, and he's going to be talking about browser fingerprinting using a stopwatch. So it's pretty interesting. Nick.
Hi, everybody.
Woo!
Yeah! My talk is pretty much research. There's not a lot of applied stuff here yet, but feel free to ask me any questions, and it can be implemented pretty easily. All right. First thing I want to go over is some of the current ways that people can fingerprint browsers. Okay, most of them rely on header and JavaScript functions to identify what the end user is using. As simple as a user agent, or something like the browser aricon project has used to identify people's browsers, or to the recent release of the tool by the EFF to look into the plugins that they're delving into. The problem with any of these is there's easy methods to spoof any of these ways of doing things. If you know what you expect from a JavaScript function, you can return that data to the person looking at it. With browser headers can be easily spoofed. Order, capitalization, all of that stuff can be mangled and spoofed by somebody. So if somebody wants to go after your site and wants to use an attack framework, they can look as close to, at least as far as the text goes, to the browser that you think they're using, the Internet Explorer, Firefox, whatever. Okay. All right. I was thinking about this because I work at a software development company, and we have a number of WAF utilities and implementation they're using. And the problem with it is, and the spoofing, is, as I said, people can take and regenerate stuff and attack your system without you even knowing it, unless you look for certain, cross-site scripting attacks or SQL inject attacks. But they can mirror your site, do all these operations, and it's very hard to detect that sort of thing until they've actually started to launch attacks against you. Okay, so what I wanted to do is find a way that we could use to identify the person's browser and make sure it was actually a browser, and make sure it was a browser that they said they were, without having an easy method for them to mangle the requests and go ahead and attack you or rip your site down or what have you. All right. I came across this. Every browser out there is optimized to render the page as quickly as best as the authors of those browsers thought possible. And a lot of them do it in different ways, but these ways are very different from how any kind of Perl or Python-based toolkit or Java toolkit is going to go ahead and go to download your site. I mean, you can download the whole site, mirror the whole thing, but Internet Explorer looks like Internet Explorer, and Python looks like Python. Okay, they download things in different manners. They go and send requests off in different orders. Okay, and they're very, very different. Because, for instance, if you use a WebKit-based browser, it tries to grab as much of the data at once and put it into memory as possible. Okay, versus older versions of Internet Explorer or Netscape, they will download things in a much more sequential manner, a lot like some of the toolkits out there will do. Right? And I went ahead and used Mod Security because it's able to do a very high precision detection of when people sent requests out. Now, I'm talking about requests because requests are usually sent off, and latency and bandwidth considerations aren't as big a problem, especially with a small page. And Mod Security can fingerprint and analyze it with very high precision, and find out exactly when people were downloading stuff. As I said, it's got high precision timestamps. You can fix up what content you're displaying to the user as it's being downloaded. So potentially you can deliver a different type of page, different type of attack. If you're going after a target, you can foil analysis. Because if you can tell if somebody's using, like, say, a Python-based toolkit to download a website, or look at what you're hosting, you can give them a completely different page than they would normally get if they're actually using the browser. All right. Well, the methods I use a lot of images because browsers tend to render things differently based upon the image types and the color depth that they use inside of those images. So what they'll do, for instance, if you have a 16-bit bitmap, a PNG, JPEG, and you separate it out with a couple of tags and a string, it's amazing how different IE6 will get that page than Firefox 3.6, for instance. Right? Sequential things like wget, links, Python, they'll all pull things down in a very set order. They'll do one, then they'll do the next, and they'll do the next, and they'll do the next. Very easy to see these things. And they can spoof as much as they want, but as long as they're doing things in the standard operating manner, it's trivial to tell that it's a framework versus a browser. Okay. Now, after you want to drill into that more, though. You want to be able to say you want to tell what browser specifically they're using. Okay. Now, what I did to do this is I had a few very, very basic HTML pages. I embedded the images. I embedded strings of text. I segmented them out with standard length strings, 255 characters. Then I broke them up with, say, BR tags. And then I had longer strings. And then the images before and after these. Okay. When the pages were downloaded, depending on the browser, you could tell very precisely which browser was grabbing these things. And the more elements you started to use, the easier it was to tell based upon the time between the different requests on those pages, as they were doing it.
Question, when you say which browser, are you talking Firefox or are you talking about the various versions?
Various versions. I've actually got it to the point after about, let me go ahead here.
You're going to get to it, that's fine.
I'm using a PDF of my slides, so it's kind of jumping around for whatever reason. Yeah, okay, here. After 5, I could tell what kind of browser it was. In some cases, I could tell exactly which one. After 10, I could tell you the version of the browser. So I could tell 3.5, Firefox versus 3.6. I could tell Safari 3 versus 4. I could tell Chrome versus another WebKit browser. It becomes pretty easy. It becomes easier the more requests are being made against your server, because the more times you have and more gaps between the requests, the easier it is to tell which one it is. And I tried.
I want to ask a follow-up question about Firefox, probably all browsers. But when you did this testing, did you also, was there any effect in tweaks and changes to the browser configuration, making user.js, such as HTTP pipelining, fudging HTTP pipelining numbers, or things like prefetch or something? Does that skew the test?
Actually, the prefix is.
Well, not so much prefetch, but like HTTP pipelining.
Actually, that's a good question. One of the biggest problems I ran into, which, let me go to here, is scripts, optimization, things like Grease Monkey was being used, different cache settings. Any of those can manually your request. But the nice thing is, if you have enough requests and your fingerprint database is large enough, you can tell exactly what method they are using. So, for instance, I was using NoScript, ad blocker, fairly extensively when I'm doing these tests, and was able to pull and eventually identify which browser was using that versus which one was not.